Hello everyone. So today we are going to cover a next level in our binary search and a very important topic in binary search. Lower bound and upper bound in C++. Okay, so most probably, I hope you all know this. What is lower bound? What is upper bound? But I just want to spare few minutes, 5 to 7 minutes, on what is lower bound or upper bound, and then I'll move on to one question wherein we will use this lower bound or upper bound, whatever is needed in our question. So without wasting time, what is lower bound and upper bound? Both of these are STL libraries in C++. Okay, it could be in Python also, it could be in Java also, in whatever language you are coding. I mostly know about C++. So both of these are STL libraries. Both of this works on sorted array. Okay, so what does lower bound gives? Lower bound gives index of element greater than or equal to target value which you have applied, greater than or equal to target value on sorted array. Okay, and upper bound gives index of element just greater than, just this is just greater than, okay, greater than target value on sorted array. So okay, let me give you an example. Okay, let's say you are given this array 5 4 3 1 0. Sorry, this is not sorted, just reverse it. Okay. You are given this array, just ignore this. You are given this array 0 1 3 4 and 5. Okay, then if you want to find lower bound of, and let's say your target is 3, then lower bound will give you this index, I mean this pointer. It will not give index in integer format at 0 1 second index, no, that we need to find. So it will give you pointer, this pointer, and upper bound will give you the pointer of 4 just greater than 3. It will never give you equal element, just greater than. Okay, now if lower bound, if you do not have 3 and if you have 4 only at this point, okay, directly after 1, or let's say 2, no 3 is present over here, then lower bound will give the greater element, just greater than target, but it will never give lesser element than the target value. Okay, if the equal value is present, it will give you the equal, otherwise it will give you the greater element. Okay, but what if there are multiple elements? So let's say it is given 0 1 1 2 3, and if you find the lower bound of 1, then it will give you first iterator, first index, which is just greater than or equal to. So while moving from the starting point, whatever is the first value which is greater than or equal to our target value, it will be given in the lower bound iterator or pointer, we could say. Okay, so this will be always what gives first index in both of these cases. Okay, it will be first index of element which is greater than or equal to target in the lower bound, and just greater than target on upper bound, but the condition is the array should be sorted. Okay, now we could apply this on, okay, we could apply this on 1D vector or array. Okay, a map and set. I mean, I can give you three different definitions how to apply it on vector, 1D vector, map and set. Okay, there are formulas for pairs and 2D vectors also, but it would be very difficult. We need to define some comparator function for that, and it becomes a little hectic. So we always go for these three methods, and whenever a 2D vector or pair of integers would be given, we would downgrade those to 1D vector or array or map or set, depending on our use case asked in the question, and then we will apply lower bound or upper bound depending on the condition. Okay, so I'll give you the formulas for lower bound. The same applies for the upper bound also. So let's say if we are going for 1D vector. Okay, Then, and if you want to find the for target val. Okay, fine. Then for 1D vector, this will be a pointer. Okay, pointer, it will be lower bound. In whatever vector you have to find, you need to give in which, from which point to which point. So if you have to find for whole the vector, you can give begin to end. Okay, if this is the vector, if this is the array, okay, this will be your end point, this will be your end point, fine, and this will be your begin point. This will be your end point, this will be your begin point. So your last is always end minus one pointer. Okay, or end minus minus pointer, not minus one, because the pointers wouldn't be in the integer format. So the last pointer would be end minus minus, because end is something outside of the array, just outside the vector completes, and begin is the first for sure. Okay, begin is first. So we'll define the starting point, the ending point. Ending point should be uh, one greater than your exact ending point. Okay, so this is where the vector completes. The element wouldn't be there at the end, but it will be there until end minus minus pointer. I hope you are clear and well. So this will give us the pointer. What if we want to find the index in zero based? Then we will do this pointer minus our starting pointer, which is v dot begin in this case. So if we minus the starting pointer, then both the pointers will be minus, and it will give you some index, zero based index. It will give you zero based index, like at which index, 2, 3, 1, 2, 4, 5, whatever. Okay, same applies for the upper bound, but it will give you just greater. For set, because set will always be in sorted order. Set will always be in sorted order. So it will always give you index, okay, or pointer I could say. And let's say you have set defined as set of int st. Then you can apply on st dot lower bound and just the value. So it will give you the index. Okay. Now this index could be v dot begin plus something, or v dot end if the element couldn't be found. If the element couldn't be found, it would be v dot end. Now, not necessarily v dot end. Okay. Let me give you one example. Let's say um let's say we are given a vector 2, 3, 6, 8, 9. Fine. And we want to find the lower bound for 1. Okay, now 1 is not present. So it will be what? 2. So it will give you what? V dot begin. Our lower bound will give you what? B dot begin. Okay, it will not give you 0. Consider this as the set. This is the set, not vector. This is the set. Okay, and now if we find the lower bound of 10, so there are no element which is greater than 10, greater than or equal to 10. So it will give you v dot n. That means there are no elements greater than equal to 10 present in our set. I hope you got my point. Okay, fine. Okay, and the third thing is for map. Okay, so if we define map of int comma int, the same thing applies for the map also. It will also give you index, the same thing, map dot lower bound and value, the same as set, the same as map. Okay, the index will give you the iterator at that point. Okay, whether map dot begin or map dot end or something, that will be your iterator of the map. Now how to get through all the elements, we will see. Okay, so let's just quickly move to one of the question, and we will realize how to use it, when to use it, okay, in which type of questions we can use it. Mostly it will be used, you will find, if you want to find something where you have been given target, or let's say you find mid element, and now you find something element which is less than equal to mid, or equal to mid, or greater than mid. So on those points, or in sorted array, you want to find something in log n of time, then lower bound or upper bound would be useful in this type of cases. Okay, time complexity of both of this would be, time complexity of both of this could be, of course, order of log n time complexity for both lower bound and upper bound. Cool. Let's just move to the question. So the question says that you are given a 2D integer array items where items of I is first is price and second is beauty. Or first item, second item, third item, fourth and fifth. There are 5 items here. Okay, first is price, second is beauty. We are also given one zero indexed array queries, and for each queries we want to determine the maximum beauty of an item whose price is less than or equal to queries of j. That means if it is 2, okay, then we want to find the maximum beauty of all the from all the items whose price is less than or equal to 2. So less than or equal to 2 price is what? This could be one case for less than or equal to 2 price. This could be another case for less than or equal to 2 price. This is 3 price, this is 5 price, this is again 3 price. So from 2 and 1, 2 and 2, 4, what is the maximum beauty? 2 or 4? 4. So we need to return 4. For the second queries of 1, it could be 4. Same way we need to do for all the queries of j. And we need to return the answer of length equal to queries. I hope you got. So what we could do for this point. Now there could be multiple items. There could be multiple items with same price. Okay, means here you can see there are with price 3 there is 2 beauty also, and with price 3 there is 5 beauty also. Of course, we can start by sorting this items array because we need to go with the we need to go with the, let's say, whatever is the maximum beauty until 2. Okay, whatever is the maximum beauty until 2, that we can store by some prefix sum, not prefix sum here. Here prefix maximum will be used. I hope we have solved prefix sum questions. So until 2 we can calculate what is the maximum. That we can do in initial phase only, while initializing only, and then we can apply for some queries j. We need to find out, we need to find some price which is less than or equal to target, and whatever is the beauty assigned to that point we can directly return. Okay, so if we have stored this in a sorted form of price, then it would be something like this. This your items array would have come to this point. But now again the question arises that we need to, okay, now just tell me, price is less than or equal to queries j. So price is less than or equal to 3. How we will find? With lower bound we will find, then price equal to 3 would be found. Or if 3 is not present, we could find some greater than 3. Okay, but not less than 3. So we need to do minus minus of the iterator at that point. Okay, if it is not equal and if it is greater. But what if we do upper bound? Then we will always find greater only. So if we do minus minus the iterator for upper bound, so let's say I find the upper bound of 3, then upper bound of 3 would be what in this case? I mean, consider this as the 1D array. Okay, consider this as 1D array where only prices are stored. 1, 2, 3, 3, 5, like this. Only prices are stored. The first values are stored. So if we apply the upper bound of 3 over here, it would be what? This 5 index. So if I do minus minus, I will always get the value 3, which can be less than or equal to. I do not need to check over here. What if I do go for the lower bound case? So if I go for the lower bound case, for 3 I will find exactly 3. Okay, cool, fine. For 4, I'll get this 5. So I need to make one if condition that if my lower bound doesn't gives me exact value, like here it has not given me 4 because 4 is not present, and it has given me 5 which is just greater. So if exact value is not present, it will give me greater. That's what the lower bound functionality is. So then I need to go to minus minus iterator and I have to go for 3. Correct? So why to put that if condition when we have upper bound in a picture? So upper bound will always gives element which is just greater than target. So if we do minus minus, it could be less than or it could be equal to. That we don't need to care because they have said that we can consider all those values of prices which are less than or equal to queries of j. Okay, so that is for sure we have make it a surety that we need to use upper bound. Now we cannot use upper bound on 2D this thing, right? We can do upper bound on a map or a 1D vector. Now what could be the better in this case? We all also need to return the beauty associated with that particular price. So we need to store pairs. So for storing pairs, it will be always useful to store it in the map. So now we will store in the map like 1, 2, okay, 2, 4. But always we will store the second value in map as maximum beauty until now. Maximum beauty until now. So first step could be what? Now you could see that there are multiple prices with same values could be present. Okay, so there are three with price 3 there are two values. Okay, 3 comma 2 and 3 comma 5. So what we can do is, first step is we can store in the map. Okay, let's say I have stored first 3 comma 2 and then 3 comma 5 came, so I replace this with 5 if the next value is greater than my original value. So that is the first step. Okay, first step is to replace for same price with maximum beauty. And second step is to apply prefix maximum to all available prices. Available prices. So now what I'll do is, in this case you can see it's a simple, so it will be stored in this manner. And now until 1 it's 2, fine. Until 2 I'll compare 2 or 4. So 4 is bigger, so I'll store 4. Until 3, 4 or 5, so 5 is bigger. Until 5, 5 or this 5 or 6, the original value of 5 which is 6, so of course 6. So as of now in this example it's their own value, but sometimes it could happen that this could be 6 and if this could be 5. Okay, then we need to store 6 only at 3 and 5 both, at both the places. I hope you got my point. Okay, fine. So this is the second step, and now we will apply the upper bound on map. Now we will apply the upper bound on map and our query will be solved. So we'll get that index, we'll do minus minus to get to the iterator. Now there could be one condition. Okay, consider this map you have written. Okay, so I have this map. Let me, and if you will apply now the upper bound. Okay, so if I got the value as something like, okay, if I got the value as 3. Okay, and if I apply the upper bound on this, I will get the iterator over here. I'll do minus minus and I could come to this point and I will return 5. Okay, that's true. What if I got the value as, what if I got the value as 0, with price 0? If I want something, then my upper bound will point to what? Something which is greater than 0, first index. So it will of course point to this v dot begin. Now I cannot do minus minus from v dot begin, because v dot begins minus minus will be something outside of the map. So if my iterator after I got from the upper bound is v dot begin, then we cannot do minus minus. That means no possible answer is left. So we will store the answer as 0 at that point, because I think they have given if no such item exists, then the answer to this query is 0. Correct? Okay, fine. Let's go on the, okay. So our first step would be to initialize the map. Okay. Now this map would needs to be sorted order. Okay. So we will have a map of int comma int, and first we will go on to all the items. So let's say there are n items and m queries, and we need to return the answer of size m. Okay, so we'll go to all the items, and as I've told you, for the same price we will compare. So while storing in the map, we will check that map of items of I0, this is the price, items I0 is price and I1 is a beauty, is equal to maximum of map of items of I0. So if it is already there in the map, then it will be map of this items I0 will be already stored, and the new one will be items of I1. So maximum of this will be stored. So this is our step first. Our second step, initially our, let's say, element is 0. We go to every element for auto ampersand, or I can put this prefix. Okay, prefix maximum for auto ampersand element in our map. So we will go to the map, our element dot second and the current prefix maximum. We will calculate the maximum of both. Okay, current or element dot second, and whatever will be maximum, we can replace that with the maximum we have got until now. Until now, so it will be replaced. Now comes our answer fielling. So we'll go to every queries. We'll find out the upper bound. So this we have to apply on map dot upper bound, and our values will be what? Queries of I. Okay, and we will just check if it is equal to map dot begin. So it is the beginner pointer. Then if it is equal to map dot begin, then if it is beginner pointer, then our answer of I will be nothing but 0 only in this case. Else we will do minus minus of it. Okay, this means the it will be degraded to 1 point. Okay, because upper bound is greater, so it will move to something which is less than or equal to our value. And now we will store answer of I as, then we will store answer of I. Okay, sorry, this both will be under the answer of I is equal to it second. It second means maps second value. As this it is pointer, we will do it arrow wise, otherwise dot. Okay, cool. Let's return the answer and check it. I hope you got this question. It is very useful for this type of questions, this lower bound and upper bound methods. Okay, in the next playlist, I'll be going to cover all the questions related to rotated and sorted arrays. Those are also very useful and to be asked in many of the interview rounds. Okay, once you know the concepts of lower bound, upper bound, you'll easily know when to apply this. So, in this type of questions, it is clearly given that we need to get all the maximum beauty where price is less than or equal to. So it's clearly mentioned less than or equal to. So we need to think something related to that. So we have lower bound, upper bound. Now think in that direction and how to get it. I hope I'm clear with it. Okay, do like, share, and subscribe. Okay, share it with your friends if you have learned a lot out of this. And in the next video, stay tuned for rotated and sorted array. Bye bye.